what if instead of a side we want to find the angle? So I put the last two cases that we saw. If x is on the top, multiply. If x is on the bottom, we divide. But what happens if x ends up on the inside? So when we end up in the situation of a missing angle, this is exactly when we end up in this situation. So how do we solve for x? Well, in order to cancel out sine, you have to do what's called the inverse of sine to both sides, and that'll cancel out the sine and put x. And the reason why we'd have to go into all the inverse ideas, but f of f inverse of x just cancels out and leaves you with whatever's inside. If it was a 2x or 3x or an x squared, anything that's inside there will cancel out. The f and the f inverse will cancel each other out. So with sine, the inverse of sine will cancel the sine out, and what we do to one side, we'll have to do it to the other. And let me just show you what that would look like. So technically, if we had sine of x equals 5/20, we would do the inverse sine of both sides, thus canceling out sine and sine inverse, leaving us with just the x equals sine inverse of 5/20. So that's just kind of the messier, that's what's going on there, right? So what you need to know is that if you end up in the situation where x is on the inside, you end up with x equals sine inverse. Now what about if it was arc sine? That is fine. Sine inverse and arc sine are exactly the same thing, just two different names. Sometimes people don't really like this because they think it's like a reciprocal, because to the -1 power. So some people prefer the arc sine. There's different reasons for that, easier to type on the computer as well. So arc sine, sine inverse, either one, I'll interchange them all the time, to be honest, mostly to keep you guys on your toes and make sure you guys know what you're doing. If it's cosine, if your function was cosine, obviously don't use sine inverse. It won't cancel out a cosine. You would use cosine inverse. If your function's tangent or cosecant or secant or any of the other functions, you would use their appropriate inverse function to cancel it, to leave you with that. So let's look at our first one here. So our reference angle is this question mark. I mean, we could call it theta. That would be better. And here is the opposite. And we have the hypotenuse here. So opposite and hypotenuse is sine. So sine of, I'm going to put theta for the question mark. It's unknown. We'll put any variable. We'll use the Greek letter theta. Pretty popular for the missing angle. So that's going to be opposite over hypotenuse. So how do we solve for theta? Or if it was x, same thing. We would use the inverse of sine. Now make sure you are in degrees. So I got 19.47. I'm going to make sure I'm in degrees, and I am. Nearest hundredth, so that's the second decimal place. And there you go. And that's it. Let's take a look at this one. So here's our reference angle right here. We'll call it theta. And we have adjacent this time. And our hypotenuse. So that's going to be cosine. Cosine of theta this time equals 6/8. So then to get cosine, or I mean theta by itself, we'll do the inverse of cosine. To get 41.409, which we'll just round that 9 up because it's to the nearest hundredth, and get 41.41.